Okay, so the first lesson that we're going to be doing, it's on page 275 of your student workbooks, and we're going to be multiplying polynomials. So lesson one, what we finished on Friday, is we were adding and subtracting polynomials, and then all of the next lessons are going to be focused on multiplying them, okay? I'm going to show you how to multiply with algebra tiles. It's very easy. If you could sort of figure this out. So let's do B together. And remember I said once you get your algebra tiles, I want you to label everything. So a rod is an X and it's positive. And these singles are ones. And then the big square is X squared. So how we do these algebra tiles is you're going to make yourself a rectangle. So at the end of this tile, you're going to draw a line down. And then with every break in the tiles, you're going to draw a line. So this is sort of a rough sketch, but what you should be able to see in here is you should be able to see that this is a big tile, right? And this would be an X squared tile, and it would be positive because X times X is X squared. These are rods, and there's 3 of them. And each of these would be an X. They would all be positive. And the reason is because an X times 1 is basically 1X. So each of these are 1X tiles. So the area, which is what I have inside here, is going to be, there's 1X squared tile plus 1, 2, 3X tiles. And that would be the area of this diagram. If we go to this one down here, let's do the same thing. So let's label an X and an X, an X, a -1, and a -1. So you want to see if you're able to get your rectangle. So every time you see a break, draw a line going down. So there'd be technically a break there, and we've got to close off our rectangle. Then my horizontal lines, there'd be a break here. Here, so every sort of space we're drawing. Okay, once you have that, you should, like I said, be able to look at this and be able to say, okay, I see squares and I see rods, and then you just have to figure out, are they positive or negative? So X times X is X squared. X times X would be X squared. So these two are X squareds. These rods, it's X times -1. So each of these rods would be considered either -1X or just -X, however you want to write it. The area of this would be 2X squareds, and then there's -4X's. Okay? Just to see if you understand this, I want you guys to try this one. So see if you could fill in the rectangle, like draw the appropriate lines, vertical and horizontal lines. Label everything, right? So we've got an X, 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 -1, and then see if you could fill in the area of this. So this is what your rectangle should have looked like. X times X, these would both be X squareds. X times -1, these would be -1X's or -X's. The area of this rectangle would be 2X squareds minus 1X. No, 2X squared. You guys, what should this be? What do you want that to be? So we've got 2 of these. Anybody have an idea?
2?
Yep, minus 2X is what that guy should be. Okay, so how these area diagrams are going to work, you will not be getting algebra tiles on your first quiz. You will be getting an Algebra Tiles on your unit exam, and it's going to be in the form of multiple choice. So you just actually have to understand how these are filled in and how they're shaded. I do not like students when we're doing multiplying. So this is what we're eventually going to be doing, is multiplying this. I don't like you doing algebra tiles because it'll take you forever. I'm going to show you how to solve this algebraically, and it's going to be much faster. So the method that I use instead of algebra tiles, you have to know how algebra tiles are going to work for the 1 or 2 multiple choice questions you'll get. But I use something called the distributive property. So can you guys go to page 277? Page 277. Okay, so these examples here on page 277, these are the examples that we just did. And I think we did B, E, and this guy. So when we multiplied x and x plus 3, so if I was just to go back to this, so here's the x and the x plus 3. This is what we got as an answer, right, using algebra tiles. I'm going to show you how the distributive property works. So what happens is, let's actually start with this one. We have to get rid of our brackets. So this is a monomial multiplied by a binomial, right? One term is a monomial, 2 terms is a binomial. We want to get rid of the brackets. So what the distributive property says is you have to take that 2 and you got to multiply it by every term inside the bracket. So 2 times x is 2x, and 2 times 1 is plus 2. This answer would be what goes in front of the bracket gets distributed or multiplied to everything within the bracket. I like putting my invisible ones in because then I'm going to say, okay, 1 times 1 is 1, and x times x is x squared. 1 times 3 is 3, and we have an x. And if you compare that to the algebra tiles that we did, the area of the algebra tiles, so let's see if we got 1x squared plus this. So if I go back here, that's exactly what we had. We had 1x squared plus we had 3 x's. Okay, if we go over to this one, so we'll just do one more. I'm going to put the invisible 1 in front of my x. So put your invisible 1 there. And we're going to distribute this inside the bracket. So you're going to say 2 times 1 is 2, and it's x times x, which is x squared. So really what that is, it's 2x times 1x will give you 2x squared, minus 2 times negative 2, or sorry, yeah, 2 times negative 2 gives you negative 4, and there was an x here. Okay. So let's look at class example 3. Use the distributive property to determine the following products. So products means multiply. We want to get rid of the brackets. How we do that is we have to distribute this 4 into the bracket. Okay, 4 times 3x is 12x. 4 times 1 is plus 4. And that would be, without doing algebra tiles, how you would get the answer. Let's look at B. -5 has to go to that term, and this term. It gets distributed into every term in the bracket. I'm going to put my invisible 1 there, and I'm going to say, what's -5 times 2x squared? That's -10x squared. Then I'm going to say, what's -5 times 1x minus 5x? What's -5 times -6 plus 30? And you are done. Let's skip C for a second and let's do D. Take that -3x. It has to go into every single term in the bracket if we're going to find the product. -3 times 7 is -21. X times x is x squared. Then I've got -3x times -2x. So -3 times -2 is plus 6. X times y is xy. I'm going to put my invisible 1 with the z. -3 times 1 is -3, and the letters are x times z to give me an xz. And this would be your answer. Okay, there's two ways to do this question. You could take this x squared and distribute it in like this, and you would get your brackets. Or just because I tend to be very procedural and I just sort of like doing the same thing over and over again, this is always like was a monomial times a binomial, monomial times a trinomial. I'm going to rewrite this to put the x squared first. And then in my bracket, I'm going to write x cubed minus 2. Okay. From here, I'm going to put my invisible ones in, and I'm going to distribute. 1 times 1 is 1. X squared times x to the 3. So this becomes product law. We add those exponents. That is going to be 1x to the 5. And then from here, I'm going to have 1 times negative 2 is negative 2, and there's an x squared. So you could write this, or remember, we don't need that invisible one. Okay, so again, if you didn't really quite get that, if I had x plus 5, and then over here I had 3x, I could rewrite this to put my monomial first and my binomial second, right? And then I could say, okay, I'm going to get rid of the brackets by distributing this in. You'll get the exact same answer. If you take the 3, you sort of just work backwards this way. So it's however you want to do it. I find half my students rewrite it to look like this. Half of them will just plug it in backwards. Okay, so this question here, so let's look at class example 4 now. What I would distribute in here is only the negative 4. So you distribute the number that is in front of the bracket. So in front of the bracket, there's a 6 minus 4, and that is what gets distributed in. Okay, you would not do this subtraction, okay, because according to the rules of BEDMAS, you have to take care of the brackets, and there's really nothing in front of the to simplify in the brackets, but multiplication must come before addition and subtraction. So I have to multiply this negative 4 in before I could do any addition or subtraction. So what I would write is I would say, okay, I have a negative, or I have a 6, I'm going to bring that down. When I distribute that negative 4 in, I'm going to have negative 4 times 8x, which is going to give me negative 32x. And then negative 4 times 1 would give me negative 4. From here, what you're going to do, the question, it actually says expand and simplify. So this is called expanding. Expanding is getting rid of your brackets. That's what expanding is. And then what you need to do is you need to say, is there any like terms that I could join together? And these would be considered my like terms. 6 minus 4 is 2, and then minus 32x. So this is my answer expanded for 1 mark you would get, and this is my answer simplified for the other mark. Oh, actually, what I should say is it's a really good habit to write your answer in descending order of x. So yes, this is the answer, 2 minus 32x, but anybody who wrote it like this, negative 32x plus 2, this is absolutely correct as well. Right? And I'd actually argue that this is almost more correct for when we get used to just writing in descending order of x. Okay, so let's look at this. We've got to expand first. So this 4 only goes into the bracket, right? That 4 goes into that bracket there. So that would give me 8x minus 12. Then you say, okay, then I have another bracket and a negative 2 in front of it. So the negative 2 is going to go into this bracket, gets distributed in. Negative 2 times 1 is negative 2x, and negative 2 times negative 6 is plus 12. You then get your like terms together. So I always do my x's first. 8x minus 2x's. 8 minus 2 is going to give me 6x's. I'm going to do my constants last. Negative 12 plus 12 cancels. Negative 12 plus 12 is 0. I don't need to write plus 0. My answer is 6x. So again, this is expanded. This one is simplified. C. So how would we do this? I've got a bracket and a term in front of the bracket. To get rid of the bracket, we must distribute that 5x into every term in that bracket. So 5x times 3x squared would be 15x cubed. 5 times negative 7 would be negative 35, and it's x times x, which is x squared. 5x times 1 would be plus 5x. So I've just expanded this first bracket by distributing in the 5x. Then I would go over here and I would say, okay, I've got to get rid of this bracket. And what's in front of this bracket that I'm going to distribute in? A negative 1. So negative 1 times 4x is negative 4x's. Negative 1 times 3x squared is not plus, it would be minus 3x squared. Okay, take a minute. See if you could rewrite this in descending order of x and join any like terms. So your highest x goes first to your constant at the end. Okay, so 15x cubed gets written first. Then I'm going to do my x squareds next. I've got negative 35 minus 3, which gives me negative 38x squareds. Then I'm going to do my x's. And I've got 5x's minus 4x's. That gives me 1x. I could put 1x, or I could just say x. And then if I had a constant, it would go at the end. There's no constant. I don't need to write plus 0, but that's what my constant would be. It would be a 0. And that would be my answer. All right, we have one more question. And then I'm going to assign the work and let you do that. Okay, one thing that's pretty big with polynomials, and I believe I have one question on Wednesday's quiz like this, and it will be on your unit test, and it's going to be on the exam at the end of the year. They love testing your knowledge of polynomials with these area diagrams, okay? So what they want us to do is they said, okay, pretend that we were to shade this entire diagram in. What would the area be? And there's actually two different methods that you could use to get the area. We know that the area of a rectangle is equal to length times width, right? That's what the area of a rectangle is, length times width. I could take this shape, and one of the strategies I could use to figure out the area of this whole thing is divide the shape into two rectangles, okay? This rectangle up here, if I said what's the area of this rectangle, the length is this guy, 3x plus 2, and this would be its width, right? 2x. So let's do this one in blue. So if I was to do the area of this top rectangle, so the area of my blue rectangle is equal to length times width. It's equal to this times this. I always like writing my binomial first, followed by my monomial first, followed by my binomial. The area of this blue rectangle, after I do the distributive property to expand, 2x times 3x is 6x squared. 2x times 2 is plus 4x. Okay, so that's the area of this. Now I need to figure out the area of, let's say, this red. So this is x plus 5. This whole thing was 4x. Does anybody want to unmute their mic and tell me what would this be? If from here to here is 4x's, this is 2x's, what would this be?
2x.
That would be 2x's as well. Yep. Because they told me that from here to here is 2x's. This whole thing is 4x. 2x and 2x is 4x. So now that I know that, I can get the area of the red by multiplying this times this. So the area of the red rectangle is equal to this times this. So 2x times, always put, if you have more than one term, it must always go in a bracket. So x plus 5. And then from here, we would distribute. Okay, so that's 2x times 1x. 2 times 1 is 2x squared plus 10x's. The area of this combined shape would be my blue plus this guy. The area of the shape would be 6x squared plus 2x squared. That's 8x squared. And then I've got 4x's and 10x's to give me plus 14x. And that would be your area. There's another way. So if this was a test question, students might choose to solve it a different way, right? Because you can solve these questions whichever way you like. So one of the ways would be what we did. Figure out the area of this guy, figure out the area of this, and add the two together. The other way that students might want to do this is sometimes it's easy, depending on your shape, to figure out the area of this big rectangle, right? So figure out the area of this big rectangle here. And I'm going to write area of big. What the area of this big rectangle would be, it would be this 4x, because this is 4x, times, I need the entire length, right? The entire width and the entire length if I'm doing the area of the big rectangle. So it would be times this guy, 3x plus 2. And you would get the area of this whole thing colored in would be 12x squared plus 8x. And then what we would do is we would subtract the area of the small, which would be this guy here. Okay, so I'm just going to erase so we could figure out what the length and width of the small would be. Okay, so this little rectangle, okay, so we got to think about this and what we need to figure out. Okay, if this is 2x, I know that this is 2x, right? Because it has to add up to 4x's. So that's 2x. Does anybody want to unmute their mic and tell me, how would I figure out this? What calculation would you do to get this purple line there?
You could subtract x plus 5 from 3x plus 2.
That's exactly what it would be. This entire thing is 3x plus 2. I just want, so I know that this whole thing is 3x plus 2, right? This whole guy is 3x plus 2. If I subtract x plus 5, I will get this length here. So when you subtract and you subtract more than one term, you put it in a bracket. When you multiply and you multiply more than one term, it goes in a bracket. So whenever we have more than one term, it must go in a bracket. This is a -1. I've got to get rid of that bracket. What do you distribute in? That -1. So what I would have is I would have 3x plus 2, x times 1x, or sorry, -1 times 1x is -1x. -1 times 5 is -5. Join your like terms together. 3x's minus 1x is 2x. 2 minus 5 is -3. So this guy from here to here is 2x minus 3. Then you would have to find the area of this. So multiply this by this guy, right? So let's actually finish this one off and I'll show you how you'll get the exact same answer. And you might be saying, okay, Mrs. Kane, why don't we just stop here? This one's easier. Some shapes, it is way easier to subtract. So you have to make sure that you could understand how to subtract. This one, I would agree that it's easier to add, but make sure we know how to subtract. Okay, so we got the area of the big. So this was my area of the big. Let's do area of the small. Area of the small was 2x's times 2x minus 3. Area of the small, 2x times 2x is 4x squared. 2x times -3 is -6x. We now have to take this guy, that's my big, and subtract from the small. So 12x squared plus 8, that's the area of the entire rectangle, minus, we have to subtract this. It's more than one term, you put it in a bracket. Okay, I've got 12x squared plus 8x. This is a -1. How do I get rid of the bracket? I distribute the number in front of the bracket, which is a -1. -1 times 4x is -4x squared. Sorry, -1. Yeah, sorry, there was an x squared there. -1 times -6x is plus 6x. From here, let's join our like terms together. Don't write this down. I'm going to give you less than that. 12 minus 4 is 8x squared. And then 8x and 6x's is 14x. This is the exact answer that we got up there. Area of my shape. So 2 different ways that you could do it. So again, I'll show you your homework questions, and then you'll have to figure out when you see the shape question, do you want to add 2 shapes together, or do you want to figure out the area of the entire thing, subtracting from the area of the small shape? Okay, let's get some of this homework circled, and then I will give you time to work on this. Okay, for question number 1, could you please circle? Let's do A, C, and E for number 1. Let's skip to number 4. And for number 4, I will assign A, B, C, G, J, and H. So expand, so that's distributive property, right? Number 5, expand and simplify. So that means there's going to be like terms. So let's do A, B. Let's do E and F for number 5. Just looking at these 3. Let's do I as well. 6 we won't do. 7, expand and simplify. Let's do 7A. Let's do B. I'd like you to put your -1 here, so you could see that. Let's do C. Let's do G and H. For H, there's 3 different brackets. So the 3x would go in the first bracket. The -2x would go in your second bracket. And the 1x would go in your third bracket. Both of these. So to me, like you got to figure out which you're going to do, like what strategy. Yeah, you guys figure this out. One of these will probably be on your test or your unit exam, you will see. And there's only so many pictures I like telling students. So I often, like you will get a picture that you've already seen very often on a quiz or a test. Okay, see if you could figure out 9. This is sort of working backwards. So you could decide, like, you could guess here, or you could distribute in each one and see which one would give you an area of this. Okay, so it's up to you how you want to do number 9 and then number 10. So that's your homework. And I think what I will do is I'll give you 20 minutes and then we will quickly go through lesson number 3. It shouldn't be that long. So I'll give you 20 minutes to do some homework or the washroom, get a drink of water. And then let's come back at 12. Let's actually come back at 12:55. Okay, so I'll just make note of that on here for myself. 12:55, we'll do this lesson. And then when we are done this lesson, you are good to go.